Okay, we are live. Hello, hello, everyone. Well, today has been a packed day full of workshops, and right now with us, we have Jared Watts from Polygon Labs to close out the day for us. He is going to walk you through how Polygon CDK works and how you can actually use it to develop your own ZK-powered L2 chains. So welcome, Jared. Thanks again for taking the time to be here with us. And yeah, with that, I'll hand it over to you.
Yeah, thanks, Sophia. I'm excited to be here. Cool. Yeah. So as Sophia mentioned, I'm going to be walking through our Polygon CDK, which is our chain development kit. And I guess the way that you could really apply this to the hackathon is if you're working in the L2 space in general, you get a general understanding of how L2s work under the hood, and how you can build your own L2, all of the components required to run your own L2 using this chain development kit that Polygon has been working on. So yeah, I'll just get started. So for those of you who don't know me, I'm a DevRel developer relations engineer at Polygon Labs. I've been at Polygon Labs for around a year now, working mainly on educating developers on how to build on Polygon ZK EVM was the focus when I joined, and now more recently we're focusing on the Polygon CDK and the AG layer. If you are aware of me, you might have seen some of my videos on YouTube. I don't have my usual setup today. I've got my laptop and AirPods, so yeah, sorry, the quality is not as high as it is as usual. But the way you can find me, the best way, if you have any questions that you're too shy to ask in the comments of the live stream, or you missed the live stream, the best way to reach me is on Twitter or LinkedIn or YouTube or Lens, whatever is most suitable for you. You can pretty much find me at Jared Watts or Jared Watts Dev. All right, so let's get started. So the Polygon CDK, as Sophia kind of kindly introduced for us, it's essentially an open source set of components, which we're calling a stack, that allows you to spin up your own layer 2 blockchains that are powered by zero knowledge proofs. So that could be a ZK rollup, that could be a ZK Validium, and you can fully customize it to behave however you want. So really, if you break this sentence down, we basically built the Polygon ZK EVM, right? And each of the components required to run a layer 2 blockchain powered by zero knowledge proofs. And we said, you know what? We've built the ZK EVM. We've been running it in production for around a year now. We have all of these components. We've open sourced all of them. Why don't we just go ahead and take it a step further and allow other people to do the same thing, powered by a lot of the same technologies that power our Polygon ZK EVM in production. So it's essentially reusing a lot of the work that we put in to run the ZK rollup and chucking it into modular components that you can utilize to actually create your own layer 2 blockchains. All right, so I like to put this slide in because there's like a meta right now where a lot of people are creating layer 2 blockchains, and a lot of them don't have a good answer for why. So why are you creating a layer 2 blockchain? What's your strategy? Like, what's the point behind all of this? Why would you even want to create your own L2 chain? And yeah, I like to include this early on because there are a couple of good reasons to create your L2 chain from a technical perspective. So the first reason I like to go through is that by the nature of public shared blockchains, you're going to have periods where the scalability of the chain that you're building on is impacted by the other applications that are building on that same chain. And what I mean by that is, naturally, if there's 100 or 1,000 apps building on the same layer 2 blockchain, let's say one of those apps has a very high period of traffic, and traffic is influxing in, going in. Let's say it's a huge airdrop or something like that. If you happen to be building on the same layer 2 chain or same chain in general, your applications or your games or whatever you're building on top of that same chain is essentially going to suffer, and your users are going to suffer in terms of how slow the chain is and how expensive the chain is to actually utilize, regardless of, you have no control over that, right? the applications sharing the same resources as you are completely separate, isolated systems from what you can control, right? You can't say, hey, slow down your users, stop telling them to do this or that. And at the end of the result is, right, your application and your users kind of experiencing these downsides because of something out of your control. So some teams come to us at Polygon Labs and say, hey, I want to experience the benefits and the decentralization of this blockchain technology to power this unique use case that I have. But I don't want to be at the mercy or, have these periods where my users say, hey, this app is unusable, and that's completely out of their control. So having your own dedicated block space and building your own chain to create your applications or create your games on top of is one of the top use cases that we see for creating your own L2 chain. The second thing I wanted to talk about was configurability, and compliance kind of leads into this as well. So we'll combine configurability and compliance into kind of the same thing. So what this means is essentially you kind of, as an application developer, right now you're picking, let's say, do I want to pick Optimism? Do I want to pick Arbitrum? Do I want to pick Polygon, et cetera, right? And you're essentially saying, well, this chain does this chain does that, and this chain has this many users and this much TVL or this much liquidity. And you have to make an important decision to say, well, which is the best chain for me technically, and which is the best chain for me from a business perspective as well. But a lot of these chains aren't dedicated, designed for your application, right? You might have a need for extreme scale, like a social application or a game, for example. You might need very high scalability and very low fees. Or if you're building a DeFi application, you might want to build on an L2 to reach a certain extent of gas fees. But sorry, I was distracted for a second. you might want to reach a certain price of gas fees, right? But you might also want a certain level of security by nature of the decentralized finance application that you're building, right? With users that use DeFi applications, they expect a certain level of security and decentralization to be in place. The other thing about this configurability point is to say, well, what if I want to completely change the game for my chain? I want to go to the extreme and say only certain people who have met certain criteria can use my chain, or only the applications or games that I'm building can use the chain that I'm building. So you can go that direction, or you could go the other direction and say, you know what, I want to build my chain and it's only for memes or meme coins or something like that. You can tailor every component, every modular component of your chain to be kind of tweaked to how you want to build it. And I've put this little diagram on the right-hand side here to say you can customize the prover, you can customize how the sequencer works, you can change things like the client, so working on multiple clients in the Polygon CDK ecosystem. We have multiple integrations for data availability, so you can choose to send your transaction data down to Ethereum, you can send your transaction data, keep it on the L2 in something like a data availability committee. You can integrate it with other ecosystems such as Celestia, and I think Avail is an integration that's possible soon. And essentially, I put this diagram here to say, you know what, you can actually take each of the individual modules, and if you're a developer, we'll look at what each of those look like towards the back end of the slides here. But each of these are individual modules that you can literally just go into the code and customize every single line to behave how you want to. And the final point here I wanted to make was in terms of compliance, and this leads into configurability quite a lot, but this is one of the biggest use cases that we're starting to see. And this is already happening in the L1 space as well. So some L1s are coming out now and saying, hey, I want to comply with the regulations and the laws of the country or the state that I live in. I want to build this application to serve the users in this geolocation. And in order to do that successfully, I need to comply with this jurisdiction's regulations. So what that means is some L1s today are starting to build out chains where you have to be KYC'd in order to actually use the chain. So you have to go through a process in order for your transactions to actually be accepted as part of that chain. So you could do something similar at the L2 level. And this is actually one of the most interesting use cases for me personally, is to say, okay, what if we kind of did this as like a middle step for, Web2 users or traditional finance users looking to enter this Web3 space or build Web3 experiences when running these traditional finance applications. Cool. So that is why you might want to build an L2. And then I put this slide here to talk about some of the kind of flaws that Polygon Labs and our team see within the L2 space alone, and why we're building this thing called the ag layer. And you might have heard about the ag layer, like Sandeep or Mihailo or other Polygon members talking about this aggregation layer, or the ag layer. And what is this all about? So I wanted to quickly mention this. We're not going to go too deep into the ag layer in this session. We're going to focus more on the CDK. But I just wanted to quickly mention what is the ag layer and what is it trying to address. So the ag layer is really about addressing the issue where, yes, you or I can create our own L2, or other teams like OKX can create their own L2 using the Polygon CDK, for example. But how does this solve anything, right? If everyone ends up with a chain that can't communicate with each other, this doesn't really address any of the issues that we've seen today. And this is a lot for the Chainlink fans in the chat, right? This is a lot of the work that Chainlink has been working on as well. So how can these chains actually talk to each other? How can you submit cross-chain transactions? How can you actually build this infrastructure of the decentralized finance of the future, or the Web3 of the future, right? How can you build this in a way that's not so intrusive to the user experience? So the ag layer is essentially trying to address that issue of, okay, well, we have all of these L2s and we've built a way for anybody to create an L2. How can we integrate them together so we don't have these two core issues? Two core issues are really the same issue, just kind of phrased in a different manner, is the fragmented liquidity and fragmented ecosystem. So this really means that you or I, as a chain developer or as an application developer even, really have a tough decision of, okay, well, if I launch my chain, I'm going to have no users. I'm going to have no liquidity. What's the incentive for application developers to build anything on my chain if I create it? The other perspective is from the application developer to say, well, there's like how many different L2s now that I can choose to build on? And if this is enabling more and more to come out, why would I choose a new one as opposed to a existing one? Or why would I create a roll-up or a Validium or a chain specifically for my applications when no one knows about that chain? No one's going to use that chain because there's no users or liquidity, right? So the ag layer is really built to address those two issues in terms of, okay, well, if you launch a new chain, there's no money on it, right? There's no capability to build DeFi applications that require liquidity to be available. There's also no ecosystem. So there's no tools available on those new chains, such as Chainlink, for example, right? Chainlink has to launch their infrastructure on the chains they want to support. As a developer, that might be important to me if I want to plug in stuff like the Chainlink oracles into my smart contracts, for example. It's also important in the ecosystem to just have a general community of people available to support the applications or NFT projects or tokens, just a general ecosystem and community available on the chain to actually power and utilize those experiences that developers are building. So the aggregation layer is a way to bridge across essentially each of these L2s without having to do it manually. So what that means is, instead of each of these L2s submitting transactions directly to Ethereum, the transaction data, they'll submit it to this kind of middle layer called the ag layer. And since the ag layer has visibility of all of the layer 2's transactions, it can then facilitate a cross-chain transaction across any of the L2s that have opted in to use this ag layer. So that's the kind of TLDR. And I said like I said, I won't go too deep into this as I'm keen to go more deeply into how you can actually build with the CDK. But just in case you've heard about the ag layer and you're wondering what it is, this is what it's really built to address. Cool. All right. So yeah, this is sorry, I didn't actually know this slide was in here, but this would be helpful for what I was talking about previously. Essentially, there's multiple L2s connected to this middle layer, and there's a common layer that receives both the transaction data and the zero knowledge proofs and enables you to solve those two issues of bootstrapping your liquidity and bootstrapping your ecosystem. All right, so now we're going to dive into the more technical side of things. So here is a big scary diagram of each of the different components. And I kind of saw this and thought to myself, well, I could talk about each of the individual components here and kind of explain how they fit together. And maybe we'll come back to this if we have time. But I really put this here to say, you know what, building a chain and getting it right is kind of scary to do yourself. And that's what the Polygon CDK is really built for, is to say, you know what, we spent a lot of money, we spent a lot of time building out our own production-ready ZK-powered chain. We've created all of the components necessary to do that. We've open sourced each of those components. And now the Polygon CDK is really just a kit that combines all of that together and places it in a kind of a logical order for you to instantiate all of the necessary components for you. And if we get time at the end, maybe I'll come back and explain each of these individual components. But for now, I want to push through the rest of the slides here. Okay, so that is a lot of kind of marketing talk, a lot of promises, but what can we actually do as developers today, right? We're at the hackathon. Why am I listening to this guy try and talk about Polygon, right? What can we actually build with this? What's ready today? And for this section, I kind of split it up into two different pathways. So I imagine most of you watching this are developers, but there is a pathway to use the CDK if you're not a developer as well. And we'll just quickly skim through how you can actually use this using our implementation provider system, which is essentially external teams working closely with Polygon Labs to power platforms like rollups as a service, for example, or just infrastructure providers that enable you to kind of utilize a UI to build your own L2 chains. And then in the following section, we'll go through the developer pathway to say, okay, here is how you can actually do all of this alone on your local machine, spin up all of the necessary components inside of Docker, and even transform that into a cloud deployment as well. So we'll start with pathway number one. And here's where I mentioned my YouTube channel earlier in this presentation here. So I do have a YouTube channel that has a couple different videos talking about the CDK and the ZK EVM in general. So if you're curious, even after this presentation, in learning more, I would recommend you watch those videos on my channel. It's just Jared Watts. And this video really walks you through how to launch your own L2 chain with the Polygon CDK in around 5 minutes. And this is probably best if you want to just get started and see what you can actually ship. And this is a no-code solution. So you can actually go onto the platform, just select a couple of different configuration options of what you want to select. So things like, what chain do I want to build it on? I think there's a couple of different options. Polygon ZK EVM. I think they're working on Gnosis integrations as well. The other options that you can select are things like, I believe, what infrastructure you want to host it on. So you want to choose to host it on the cloud, or you want to choose to host it on-prem, and a couple of different configuration options through the process. And essentially, this will lead you to a point where, okay, I've deployed my own L2 chain. It spins up all of the necessary components of things like the bridge. It spins up a faucet for you. It spins up all of the smart contracts required on the L1 level. It spins up all of the node components at the L2 level. So things like the sequencer, the aggregator, synchronizer. And if you don't know what those words mean, since we have an hour today, I can probably walk through the diagram a little bit more towards the end here. But if you're not interested in coding, if you don't want to do a super deep dive, you just want to kind of get started playing around, the implementation provider system is best here for you. And I'll quickly just mention what this is. So essentially, this is what a lot of people call roll-up as a service providers, or RAS or RAAS. And this allows you to essentially, this company or this team of engineers will run the infrastructure for you required to build an L2 chain powered by the Polygon CDK. And this allows you as a business person or an ecosystem person to really focus on building out your ecosystem, building out the other components of your chain, and you don't have to worry about the technical side of things. And as I mentioned, you can really launch all of the essential components. You can even do things like use custom gas tokens. You get literally every required part for a helpful developer experience, like a block explorer, an RPC, a bridge, a faucet, etc., etc. So you really get everything out of the box with this process. Obviously, I guess I should mention this path, you're going to pay like you would pay Google Cloud or AWS to run this infrastructure for you. You would pay an implementation provider to run this infrastructure for you. But I should mention, if you use this video, you can get your own testnet for free, running in literally under 5 minutes. And then I'll walk through in this video, you can actually build an application testnet that you create. All right, so that was kind of the business path. And now let's talk about the developer path. So yeah, this is what I mentioned before. Each of the components is split up into its own modules. So this is available on our GitHub. So if you just search like Polygon GitHub, you'll be able to find this. And this is each of the components that make up the Polygon CDK chain. So we have things like the node, we have the actual smart contracts, the roll-up contracts that get deployed on the L1. We have how you can integrate different data availability layers. So if you want to use a data availability committee, for example, you would use this repo. Or if you want to integrate with other DA solutions like Celestia, you can kind of learn how to plug and play that and replace this module, for example. You could learn how the prover works under the hood. You can learn how the bridge works under the hood, how the bridge UI is built, and how users can interact with that. So really, I just put this here to say, hey, this is all open source. You can dive deeply into every single line of the code of how it works and exactly what you're actually deploying when you use the CDK. Okay, so for our devs here, what we are working on as part of our CDK kit is this Polygon CDK Kosis package. So here is the GitHub repo. I think I do have the link in the next slide. So I may actually paste that in the comments as well. Just give me 1 second to walk through this here. We have this Polygon CDK Kosis package. And what this is this was actually new to me as well, but Kosis is essentially saying, okay, here's how you can define how you want to spin up different services and components and how they kind of interact with one another. So what that really means is essentially each one of these components is a Docker container or multiple Docker containers. And what that means is you can then, using this Kosis package, spin up each of those Docker containers in kind of chronological or just sequential order to say, okay, let's first deploy a local L1 so I can deploy my rollup contracts, so I can deploy my L2 on top of the L1, so I can deploy this and this and this. So it really just goes through step by step in sequential order, how you can actually set up all of these components. And yeah, we're going to be working on a lot on this. I'll personally be working a lot on the developer experience of this tool moving forward. But for now, you can actually just clone it. And I will just quickly grab the link for you. Give me 1 second here. So I can chuck this in the chat here. Cool. But really, it just sets all of the components up for you. So here is the link. I'll chuck that in the chat. Cool. Thank you, Sophia. I'll be able to forward that for me. Thank you. Cool. So yeah, you just clone it down. and you will, I'll put a little disclaimer here, you'll need a couple of different tools installed if you don't have them already, but these are really common developer tools like Python and Docker. I think are the main two, and maybe a couple of Python libraries. But there is a command as part of the README that says, hey, you'll run this command and check on your computer, have you got all the necessary requirements installed, like Docker, Python, etc., and you'll be able to run that and install anything that you're missing as well. So once you've cloned it down, you can run one single command called Kosis run, and you pass in the params file that defines all of the behaviors and configurations of your CDK chain. So things like, do I want to deploy a custom gas token to use as the gas token for this chain that I'm building? There's like a few hundred lines of configuration files that you can customize to however you want this chain to behave, and go ahead and run this command. It will start running through every single process. So I think in the next slide, I actually walk through what it does. Cool. Yeah, so what it does right now by default, and obviously you can kind of turn off each of these steps or turn on each of these steps depending on what you want to achieve. But what it does by default right now is deploys a local L1. So it's kind of just running one of the open source Ethereum nodes, mocking what an L1 experience looks like. It then deploys the ZK EVM rollup smart contracts for you. So this is the contract that actually receives batches of transactions and also receives zero knowledge proofs to verify those batches of transactions. It then goes ahead and deploys essentially what is the L2, which is a node running a couple of different components. So it's running all of the necessary pieces and the databases to store the information of those pieces. So what I mean by that is it's running things like a prover to actually generate zero knowledge proofs to verify batches of transactions. It's running the synchronizer to execute those batches and send those batches down to your data availability layer. It's running the aggregator to actually start the prover process to say, hey, give me those batches and I'll generate a proof for you. It's, of course, doing the sequencer, which is actually, I got that confused with the synchronizer. The sequencer is what's executing the transactions and sending them back down to L1. Synchronizer is kind of working in tandem with the RPC to allow your users to actually send transactions to your L2. And yeah, these are the steps that it runs through. I'll quickly walk through the final two steps. Is it actually deploys the bridge infrastructure. And here is the interesting part of why I wanted to mention the ag layer, is to say, hey, here's where you can actually choose whether your chain is going to participate in this ag layer that allows you to have this cross-chain L2 communication. And then finally, what I'm calling the observability stack to say, hey, here's like dashboards and analytics to see the usage of your chain. So how many people have bridged? How much funds do I have on the chain? How is my chain performing, right? Is it crashed? Things like that. Hopefully your chain is not crashed, but it's just an example. And here is a little snapshot of that params file that I mentioned. So this really allows you to customize everything, right? So you can customize each step of that process that I just walked through to say, hey, do I want to deploy the local L1? Or we're working on things like, would I rather just deploy this to Sepolia or public testnet? Do I want to actually deploy the ZK EVM contracts? Or do I want to work through individual steps and inspect really deeply what's going on in one individual component? And then on the right-hand side here, I did this little ice cream cone diagram to say, really, you're building like an ice cream cone, right? Where, you know, when I get ice cream, I get like 5 scoops of it. But the ice cream cone that you're building is like, okay, well, do I want to opt into this as my data availability layer? Here's how I want my sequencer to behave. I want it to be, well, in the future, the options will be more diverse. Right now, it can only be centralized, but we're working on decentralizing the sequencer as well. You can choose what kind of prover you want. Do I want it to be type 1 ZK EVM, or do I want it to be type 2 ZK EVM, and so on and so forth. So you're kind of like slapping on the layers of ice cream, where you're like choosing the different customizations of the different components that you want. And yeah, here is the video that I actually walked through this full process. So this one's about half an hour. where I walk through the entire process, start to finish, cloning down this repo, setting up all the dependencies, walking through all the commands, and then actually explaining like what did we actually just do, walking and shelling into each of the components to say, here's what this component's doing, here's how you can play around and kind of explore the different components that you've deployed as part of this L2 deployment process. And really just walk you through start to finish, creating your own L2 DevNet with this Kosis tool. So yeah, I'll leave this QR code up for a couple of seconds here while I take a little sip of water. Cool. Yeah, so I think that is, I did actually want to show one more slide, but maybe I will dive into the comments to answer some questions first before I continue, as I know we're at the half-hour mark here.
Yeah, totally. I saw already 2 questions. So we have, is Polygon TDK trying to link blockchains like OP superchains?
Yeah, that's a great comparison. So I think what the OP system is doing is very comparable. So for those of you who aren't aware, I think I'm obviously not an expert in this, but the OP stack is kind of comparable to the Polygon CDK, where the OP stack is a set of open source components that allows you to create an L2 using the optimistic rollup setup, where I won't dive deeply into like how optimistic rollups work, but essentially you can create similar to what Optimism is running in production using the OP stack. And then the super chain, I honestly don't know a lot about it right now, but I think it is trying to achieve the same thing within that ecosystem. So it's going to say within all of the chains that have launched with the OP stack, how can we solve this interoperability issue among those, and how can those OP stack chains communicate with one another? So I think it is very comparable to OP stack with Polygon CDK and the ag layer with the superchain setup. I don't know a lot about the technical details of OP's system, but yeah, like the concepts are the same, I would say.
Awesome. And we have one more question from TP. What kind of system do we need to be running to create L1, L2, and all that hooty up?
Yeah, so it's really like a question of, well, why do I want to run my L2? And maybe I can go back to like the very beginning slide here. Of like, why do you want to launch an L2 in the first place? And I think this is actually a valid question. It's a funny way of putting it, but it's like, why bother launching an L2, right? Why are these companies creating L2s? And obviously there's like a business perspective of this as well of, is it going to help my brand grow? Am I able to even profit from running this L2 chain, depending on how you set it up? But from a technical perspective, is kind of what I wanted to focus on, as that's probably where I'm better qualified, is to say, well, if you want to build a decentralized application, you want the benefits of a decentralized backend, the current solutions available is to say, well, do I want to use a public chain, which is shared infrastructure among n number of apps, right? And any one of those apps can cause a lot of scale to be coming down to the infrastructure that you're using. And this can often cause things like, well, an application that has nothing to do with my business or the use case that I'm building is causing my application to suffer and slow down or become more expensive during those peak times. And you might want to create an L2 for that reason, or you might want to create an L2 to support a specific kind of use case that you're trying to build. So that might be a high scale game where you only want your game to be using that chain infrastructure, or you might want to use it for use cases like compliance, where you customize some logic of the sequencer or one of the individual components to say, okay, I want the benefits of the decentralized backend, but I don't want to have that shared infrastructure. I want this to be kind of my backend, and in a mental model where coming from Web 2, it's like, well, every company today is running their own backend. No one's sharing this infrastructure, right? So it's kind of coming from that perspective to say, well, why would I bother with these L2s? There's a couple of different reasons that you might want to do so. Sweet. I did want to share like one other slide that I didn't include in this one. So give me 1 second here, sorry. And present. Okay. So I just wanted to walk through like how your L2 is actually going to work under the hood. So let me copy this slide across to my deck really quickly. All right, there we go. Okay, so I'll present again. Oh, it's not appearing. Okay, let me share my full screen. Sorry about this.
Oh, you're not seeing it? It is being shared.
The new
You're
slide?
not seeing it?
Yeah, I can see this one, but I wanted to show a different slide here. I just chucked it in there.
Oh, okay, great.
Yeah. I'm just gonna reset it.
In the meantime, if anyone has any questions, feel free to drop them in the chat. Jared is almost finishing, so take your opportunity while we have him here. And yeah, let me put it in.
Sweet, thank you.
It's
Hopefully
working
it's at
now.
the end here. Nice, there we go. Thank you.
Awesome.
Cool. Yeah, so I just wanted to quickly, since we have like a couple minutes left, I wanted to talk about more what are the components you're actually deploying and how does this actually work under the hood. So this is going to be like an overview of how the L2 that you actually create works, as opposed to like how the chain development kit allows you to create these L2s. So this is going to be a little bit of a deeper dive into what you're actually deploying. So this diagram on the right-hand side here is a couple of, it looks a bit scary at first, but it's really a walkthrough of how a transaction gets handled from a ZK-powered layer 2. And this is one of the benefits to launching a ZK-powered chain is that your transactions are finalized on layer 1, at least using the Polygon ZK EVM stack, in around an hour, which means you can actually submit and verify the zero knowledge proof on the L1, and that means your users can withdraw their funds when that zero knowledge proof is verified. So users, instead of waiting in an optimistic solution, you might typically have to wait 7 days using the standard bridge. There are ways around it with third-party bridges where you can get your funds quickly. But the standard bridge, you have to wait for that 7-day waiting period for your transactions to actually go through to the L1, or withdraw your funds to the L1, I should say, sorry. Your transactions are going through just as fast, but you're not allowed to withdraw your funds from the L1. Whereas in a ZK solution, such as Polygon ZK EVM, you're allowed to withdraw your funds as soon as the proof is verified, which is typically around an hour today. So the way that this all works is essentially your transactions go into what's called the transaction pool. And if you heard me kind of talking about the L2 node and the synchronizer, the sequencer, etc., this is what's happening at this layer. So first, your users submit their transactions through an RPC, just as you would with Ethereum, and it goes into the transaction pool, the pending transaction pool, just as it would with Ethereum. So instead of a group of nodes picking up those transactions from the mempool and kind of executing them in the way that Ethereum works, in L2s, you have this node software called a sequencer. So within a node, there is one component of that node, which is called the sequencer. And the sequencer has a huge role to play. And the two roles that are crucial to this ecosystem that it plays is it goes ahead and executes all of the transactions received from the layer 2. And it also sends all of the transaction data down to typically Ethereum in a roll-up situation, or to whatever data availability solution that you're using, depending if you customize that or not. So the sequencer really has the two most important parts. It says, hey, I'm going to send them to my executor. It's going to execute those transactions, give me the result back. The result of that execution is kind of immediately sent back to you as a user within 1 or 2 seconds to say, yes, your transaction was approved, or no, your transaction failed for whatever reason that we received back from that executor. Maybe you don't have enough funds, maybe there's an issue in the smart contract, etc., etc. So the sequencer sends it to its executor, receives the result, gives that result back to you. And this all happens in around 1 or 2 seconds. And if you can see the green arrows on the left-hand side here, this is the state the transaction is kind of working through as it progresses from L2 to L1. So when it was in that pending transaction pool, it was in a pending state. Now that we've executed it and given you the result back, it's in what's called a trusted state. So the trusted state is when it's been confirmed on the L2 and the result has been delivered back to you. So the way that I like to think of trusted is like, do I trust whatever L2 I'm using? Do I trust them to give me the right result back? Do I trust the sequencer or the nodes to give me the right result back? And if you do trust the L2, you can, well, regardless of if you trust it or not, you can continue to use the L2 as if the state has been accepted already. So that means if I'm minting an NFT, this full process happens from pending to trusted within around 1 or 2 seconds. We then can continue as a user to use our funds, interact with the applications freely on the L2 level. So that means from an application perspective, you don't have to build these like minute-long waiting periods or have these kind of harsh UX experiences for your users when building on an L2. The next step, as the sequencer sends the transaction data to a roll-up contract deployed on Ethereum layer 1, and of course, there are customizations to this, but we're going to assume this is the setup that you have with the L2. It sends transaction data down to the rollup. And what that actually means is it's a two-step process where it first serializes the transaction data. So it takes all of the information saying, okay, here's who the transaction came from, here's who it's going to, here's what functions it's executing, and it serializes that into a format that a smart contract can read. And it does that for each of the transactions and then just like sticks it all together. It just concatenates each of those serialized transactions into one. So basically put it in a form that a robot can read and stick it together. So it's actually quite simple. It sends that joined result to the smart contract. Once it's reached the smart contract, that's where we reach this third state, this third green arrow here called virtual state. And this virtual state represents a state where the batches have been sent to Ethereum. However, they might not be correct, right? Those batches might not be true. And what that means is to say, when we're in a point in time where we have multiple sequences, the sequencer is decentralized, that sequencer might try and submit a batch of transactions that benefits them greatly and is not a real transaction. So I might operate as a sequencer and say, yeah, somebody sent me $20 million and I'm going to send that to Ethereum. Once it's reached the rollup, it's there, right? It's reached Ethereum, but it's not necessarily true because sadly, nobody sent me $20 million. The next important step is to say, okay, the rollup has received the batches of transactions. And this is like, maybe you're thinking, where's the zero knowledge proofs in all this, right? It's called a ZK rollup. Like, where's the proofs actually happening? And this is where it actually occurs in this fourth step here, in this consolidated transaction phase. So once it's reached the smart contract on Ethereum, it's then going to introduce this aggregator. So the aggregator is constantly checking. I think it's around once an hour that it does this on on production Polygon ZK EVM today, it constantly checks the rollup contract for new batches. And the reason it's doing that is because it wants to prove those batches are correct using zero knowledge proofs. So what it's going to do is it's going to say, hey, Mr. Rollup contract, do you have these batches ready for me? And if it does, it receives those batches of transactions and sends it to a prover. So a prover is a bit of a beefy machine that you're going to run. It's going to run the logic required to actually generate zero knowledge proofs of batches of transactions. So essentially the aggregator plays the role of saying, hey, give me the batches, I'll send them to this prover to actually verify whether or not those are correct. The prover is only able to generate zero knowledge proofs of valid blocks of transactions. So the prover is then going to say, all right, yes, that looks good to me, using kind of complex maths under the hood to say, yes, that looks good to me, give that zero knowledge proof back to the aggregator, who can then send it back to Ethereum. And then that is the final stage that we've reached. So once that zero knowledge proof reaches Ethereum, we have reached the consolidated state. And this is a point in time where you can trust that Ethereum has verified the zero knowledge proof to say, yes, that is a valid proof that proves the batch of transactions that occurred. So what that means is to say, Ethereum's nodes, and the reason we love Ethereum, where we have like 1 million validators running each of these transactions, they're the ones verifying that this proof is true. So they receive the proof and run the code on the rollup smart contract to verify whether or not the zero knowledge proofs. And that's why you'll hear a lot of the time that ZK rollups inherit the decentralization of layer twos, which is true in some senses and untrue in other senses right now. Cool. All right. So that was the final slide that I wanted to share, just like how the L2 that you're deploying actually works under the hood when you're building with the Polygon CDK. So that's wrapping up my presentation.
Amazing. Thank you so much, Jared. I don't know if there's any questions someone wants to drop on this final minutes. Last chance to do it. I'll give you guys a couple seconds. And if there's not any questions, we will wrap it up. So yeah, take the opportunity right now. If you have any questions, just drop it in the chat. Seems not. Seems that we're good.
Cool.
Well,
yeah,
thank you
Sophia.
so much. Yeah, thank you so much, Jared, for taking the time. Again, Polygon has $50,000 in prices for block magic. Lots of prices. Go to our dev post page, check all the requirements, all the challenges. And if you have any questions, either ping us and we'll pass your questions to Polygon team. Feel free to do it through our Discord channel, or ping Jared. He will definitely be happy to help you guys as well. And yeah, with that, thank you so much, everyone. We'll be back tomorrow with a couple more workshops. And yeah, happy hacking. Thank you so much, everyone. Bye.